Hi, in this video we are going to talk about abstract data types and basically what's the difference between abstract data types and data structures. So let's get started. What is an abstract data type? Basically, this is the model or the logical description for a certain data structure. It is like a supertype in programming, in Java for example, an interface where we define that what's going to be the behavior, what methods we would like to implement. So we just define what methods and functions the data structure will have, so we define the basic behavior without the concrete implementation. We don't know that how the behavior is going to be implemented with the help of two for loops or while loops or nested if-else checks or whatsoever. We just know that, okay, what's going to be the behavior. What's very important is that it is just a model. The abstract data type doesn't specify the concrete implementation or the programming language. Basically, this is what the user knows. For example, we have the stack. We know that we would like to have three methods: the push method, the pop method, and the peek method. The push is going to add an item to the data structure. The pop is going to return and retrieve an item from the data structure, and the peek is going to return an item without removing it from the data structure. But we know nothing about the concrete implementation, that how are we going to store the items in the data structure, how we are going to implement the push method. We just know that push, pop, and peek methods are needed, and basically this is why the abstract data types came to be, because it's going to define these behaviors. The data structures, on the other hand, are the concrete implementations, so the actual representations of the data. The aim is to be able to store and retrieve data in an efficient manner. What we are looking for: we would like to be able to insert and find items in ordo1, so constant time complexity, and we would like to be able to retrieve items in ordo1, constant time complexity as well. Of course, this is the best case scenario. Sometimes we are not able to reach this threshold and we are not able to do every operation in ordo1 time complexity, but this is what we are after. So for example, arrays, linked lists, and binary trees are data structures. We have the concrete implementations. So we have the abstract data type, just the model, just the supertype, just the specification, and the data structures, the concrete implementations. So we have the stack abstract data types with the concrete behaviors. And we can implement stack with the help of array or linked list data structures. We have the queue abstract data type, and we could implement queue with the help of array and linked list data structure. We have the priority queue as an abstract data type, and the heap, the concrete implementation of the priority queue. We have dictionaries and hash maps and arrays as the underlying data structures. So it's very important that abstract data types and data structures are not independent from each other, in the sense that abstract data types are the specifications, and every abstract data type have an underlying data structure that's going to implement the behavior that has been specified in the abstract data types. So that's the difference between ADTs and data structures. Thanks for watching.